Action.
Hello students, how are you? I hope we all are fine. Today our section is Rutherford model of atom. In previous session we already discussed the Thomson model of an atom. He does not explain properly the structure of the atom. His structure of atom is defined with watermelon. The negatively charged particle is embedded with the positive part of the atom. But he does not explain properly. That's why his drawbacks were overtaken by Rutherford. He discovered another model of an atom. He used some particles here, that is alpha particles and gold foil. The digital part is called zinc sulfate. What is the alpha particle here? First of all, he take a helium element. Helium elements, what is the atomic number of the helium element? Helium 2. In this helium element, it has 2 electrons, 2 protons and 2 neutrons. It will become alpha particle, it loses electrons. Loss of electron is nothing but what? Loss of electron is nothing but cation. If lose the negativity, we get positive charge. Like that, this element also loses their electrons and it get positive charge. Here 2 electron it loses, it become plus 2. This is the alpha particle here. This alpha particle is used in his Rutherford model of an atom. In his experiment, these alpha particles are put it into a lead box. See here this diagram. This alpha particle, put it in a lead box. This lead box has small hole. Through this hole, these alpha particles are passes into the gold foil. Now coming to the second one, gold foil. What is the gold foil here? In our food containers have a silver foil. It is a very thin layer. Gold foil is nothing but what? Very thin layer. He used gold here because of gold is rich particle. That's why he used the gold foil. This very thin layer. Because of the thin layer, the electrons are easily move on the foil. Let us see. The gold foil is fixed here. When we pass these alpha particles on the gold foil, what will happen? If these alpha particles are penetrated into this gold foil, here he fixes a digital zinc sulfate digital screen here. He fixes a zinc sulfate. This is the zinc sulfate digital screen. When the alpha particle passes through this gold foil, this is the gold foil. This here the electrons are penetrated through the gold foil and enter into the digital screen. Enter into the digital screen. But what happened here? And one unexpected thing is happened. These alpha particles are discreted in different angles. These alpha particles are discreted in different angles. Rutherford don't expect this type of structure. The electrons are discrete, scattered in all directions, not in a particular direction. Some are deviated. Some deviations also occur in these alpha particles. That's why he does not completely explain the structure of the atom. This is the main drawback of this Rutherford model of an atom. For example, how the electrons are deviated in this digital screen. A person is standing in front of a wall. He throw a ball to this wall. What will happen? After hitting the wall, the ball hits the wall, it deviated back. Just like that, these electrons also deviated from the digital screen. We'll take another model. This is the gold foil, very thin layer. In this gold foil, the positive and negatively charged particles are arranged like this. These negatively charged particles are arranged in a different manner. When the alpha particles are enter into these foil, if it is negatively charged alpha particle, positively charged alpha particles are passing through this foil. When it hit the negative charge, it will pass on the foil. When it hit the positive charge, for example, here is a positive charge, here also positive charge. Hit the positive charge, it is deviated from the foil. These unexpected deviations are occurred in Rutherford model. Another drawback of this model is an electron revolve around the nucleus. This is the nucleus. Electrons are revolve around the nucleus. These electrons, when we are revolving around the nucleus, it gets some acceleration. Because of this acceleration, the energy releases from these electrons. When the energy releases from these electrons, what happen? When the energy releases from the electrons, what happen? The electron energy decreases gradually. When the energy decreases, what happen? It comes into the proton place, nucleus place. When it's coming to the nucleus place, the atom is unstable. If we have unstable atom, there is no formation of molecule, there is no matter. Matter is nothing but what? Any matter, either pen or pad or paper, is made up of molecules. These molecules are made up of atom. Here, the atom is collapsed. Why? Because the energy of electron is decreased, it finally coming to the center of the particle. The atom is collapsed. When the atom is collapsed, what will happen? There is no stable atom, there is no molecule, there is no matter. This is the main drawback of the Rutherford model. Basing on his drawback, another scientist, Niels Bohr, proposed a new atomic model. We will discuss in the next section. If you like my video, please share my video, like my video. Thank you. Subscribe my channel.